Hello students, welcome to this session of your computer class. So first of all, we supposed to discuss about that logical operator, the same chapter which one we are discussing previously. The logical operator and operators in Java chapters, it is a part of your Java chapter, operators in Java. So this one, before going to discuss, we should little bit we have to discuss about the logical meaning of this word logical. And logic means where the answer can be given in true false. The problem where the answer can be given in true false, that all things are called logical problems. And here in the computer we have a capability to calculate all types of logical calculations. So there are three logical operators in our Java, and we are supposed to write these logical operators with the logical types of expression and also relational expression and logic boolean type of data. That you know already, the boolean type of one category of data, it is there, boolean data, and this boolean data can be used with these logical operators. And relational expression also you can expression, that all you can write with the logical operator. So these two kinds of data, on these two way it is possible to write. But other values like your integer value or fraction value or your character value, they are directly cannot be written with these logical operators. We cannot write that all things with the logical operators. So the logical operator, to implement only, they need only two category of values, that is your boolean values, which all are whose answer can be boolean value, a true false type of answer, which all are, that is your boolean values, and your relational expressions. Relational expression, that means where there is a greater than, less than, equals to, not equals to, greater than, equals to, less than, equals to. These all types of operators where it is used, that is called your relational expression. So these relational expressions can be used with this logical operator. So the benefit, why to use these all things? The benefit is that only to reduce the complexity of the program, we are using these logical operators, and where the program or conditions, where there is a constraints are more complex, where many conditions are there, to represent them in our programming, we may find difficulties. Our program will be lengthy and our program will be cumbersome and difficult to understand. So that is why this logical operator, if you use, you can make it simple and your program will be short and easily all the conditions can be expressed in one sentence or one statement. Okay, so that is why we are using these logical operators. So we will discuss here AND logical, OR logical, and NOT logical. And that is AND logical operator, OR logical operator, and NOT logical operator. So first of all, we will see the AND logical operator. AND logical operator, when you write the symbol, we are writing here the ampersand sign, two ampersand sign. Remember, two ampersand sign you have to use. Here AND you will not write in the expression, you will not write AND. You will write two ampersand sign. That means it is a AND operator. Okay, and whenever you will write this one, you have to use this two ampersand sign, and in the infix notation you will write, and it is a binary operator, remember. So in middle you have to write the operator, and both side of this operator you have to write the your boolean value, or you can write your relational expression. So the every logical operator having a standard rule of execution, certain rule it is already following to execute answer and gives the answer in true false. So this AND operator also gives answer in true false, this OR operator also answer in true false, and NOT operator also gives answer in true false only. Okay, and when you are writing this one, the writing rule as well as the execution rule, it is different each other. So the writing rule, that means your end operator following a certain type of execution rule and gives the answer in true false. So what is the rule? That one in a truth table we can represent it. First one, end operators rule. So this one, it is OP1, OP2 and OP1 and OP2 answer. So this one, if it is true, this one false, then answer is false. Then this one, if false, this one is true, then answer is false. Then if it is false, this one also false, then answer is false. Then if it is true, this is true, then only answer is true. This is the rule it is following by AND operator. First, this OP1 means operand 1, or OP2 means operand 2, and this one is the final answer, this one. Okay, so suppose you will write expression, OP1, format of writing is this one, OP1 AND operator, thereafter OP2. Like this manner you have to write. And here OP1 and this one, it is the AND operator, then OP2. And OP1, OP2 after writing, then when this one is true, suppose this one is true, this one is false. So the whole expression answer will be what? False here. And if this one it is false and this one is true, then whole answer, this one, whole expression's answer is false. This one. And this one, suppose this one is false and this one also false. Both are false. And both are false, then answer also false. And if this one is true and this one is true, then answer gives us true. So this formula computer follows whenever it evaluates the AND operator. And AND operator require two, OP1 and OP2, both the cases. This both require a relational expression. Okay, both the relational expression require or Boolean type of value that I told you. And middle you have to write the operator and both side you have to write the two expressions. Okay, so example you see A equals to B and A equals to C. Okay, we have to compare to a value of A is equal to B or not, and A value it is equal to C or not. Okay, so this one to know, to express it in the expression, two conditions. Okay, and first of all computer will evaluate this one. First of all A, B, C value you have to give, and after giving the value A, B, C, then a computer will compare this one A value is equal to B or not. And if it is equal to B, then it is true. Suppose it will found true, then it will come to this one, it will check. And if A is equal to C or not, it will compare. And if both are this one equal, then answer according to the table, answer will be true. Suppose this one is false. If this one is false and this one is true, then answer will become false. The whole expression's answer, this one answer will be false. Okay, and if this one, if it is a false and this one is true, then it is a whole answer, it is false. And this one is true and this one is false, then our whole answer it is false. So rest of all cases it is false. Only in the one case it is true. So that is, if it is first one is true and second one also true, then both are true, then answer is true. This is about your what? AND operator. Then we will see about the OR operator. OR operator rule is like this manner, same way, but just its rule is different. It is just opposite of the AND operator. So the OR operator, OR symbol is this pipe symbol. Two vertical lines are called your OR operator symbol. And its rule of truth table is like this manner. Truth table, this one OP1, OP2 and OP1 your OR OP2. This one is true, this one false, answer is true. This one false, this one true, then answer is true. And this one it is true, this one is true, then answer is true. This one false, this one also false, then answer is false. So like this principle it is following OR operator. And this one OR operator, when you are writing that time, we should follow this rule always. And here also same way you have to write. This is also binary operator and it is in fixed notation we are writing. So how to write this one? OP1, okay, or OP2, this one, like this you have to write. So OP1 is this one, OP2 means operand 1, operand 2. So this one, if it is true, this one false, answer is true. Okay, this one false, this one true, then answer is true. This one true, this one both are true, then also answer is true. Only in the case of when this one is false, this one is false. Both are false, then answer is false. So this way the table it is says that according to the table it evaluates it. So example, you see how to write this one expression: A equals to B or A equals to C. So three values are there. If you want to find any two value are equal or not. So A value is equal to B or A value is equal to C. So like this manner if you want to write, then A equals to B, one relational expression, and A equals to C, this is also relational expression. So if it, first of all it will evaluate it, and if this one is true and this one is false, then as a whole this expression's answer is what? True. And if this one is false, suppose this one is false and this one is true, then also answer is true. Whole expression answer will become true. And this one, if it is suppose false and this one is false, both are false. A is not equals to B, A is not equals to C. Okay, both are false. Then whole answer it is false. It is false. Suppose this one also true and this one also true, both are true, then answer is true. So this way you can write, and also in different way this OR operator also you can write. So first of all, this OR operator can be written in other form also. If A greater than 50 or B greater than 50, this way also you can write. A greater than 50, value of A you will provide, and B value also will provide. First of all, you have to supply the value of A, B. Thereafter, computer will give this condition to the computer. If A value is greater than 50 or B value is greater than 50. So among these two, any one if satisfied, then as a whole answer it is become true, and answer according to true it will work. So like this manner, this is about the OR operator. The next operator it is that is NOT operator. NOT operator, it is a unary operator. Remember this NOT is a unary operator, and it can be applied upon the format of your prefix notation. Prefix notation you will write it, and then this is a NOT. NOT operator symbol is exclamation symbol. This one exclamation symbol is representing NOT operator, and this one actually unary operator. And in prefix notation you are writing first operator, thereafter the value or expression, and it is unary, one operand only required. So first of all here how to write, just you see, and because it is a unary operator and one operand it require, so table you can prepare the table also. So here 4 options will not come. Here only 2 options will come. This is OP1 or operand 1, and the result not OP1, like this manner. And if this one is true, then the answer will false, and this one is false, then this one will answer. 4 options will not come, because they are what? They are binary operator. 2 operands are required. So that is why there is a 4 alternates. Okay, but here only 2 alternates, because 1 operand only it is using here, so it is 2 alternates. So how to apply it? Here NOT you will write first prefix notation, then in the bracket OP1, operand 1 you have to write inside the simple bracket. Okay, so this one it is first of all your exclamation symbol, then thereafter OP1. So this way you have to write format of writing. The next thing it is that how to apply this one. Not A greater than B. This one. If this one is true, suppose A greater than B is true, then as a whole answer will become false. Just opposite of it. Whatever the operand answer, just to make it opposite. Suppose this one is false and as a whole answer is true. Complete the expression answer will be true. Just to make it opposite. And if the OP1 answer is true, then the final expression answer is false. And if the OP1 answer is false, then the answer is, the whole expression answer will be false, true. Okay, so suppose I will write here not A equals to B. So this one, that means what? If A equals to B, suppose this relation, if it is true, then this complete expression answer will be false. Okay, suppose this one answer it is false. Suppose A value is not equals to B, it is not equal, then as a whole answer it is what? True. So these three are the operators which all are, it is that your logical operators. This one not, or, and your and. Okay, so this is all about this class.